Welcome back. We are at lesson 3 of module 4, machine learning with Python 3. We are discussing about classification part 2. We looked at 4 algorithms and 4 models, 4 algorithms for classification in part 1. Now we continue with classification, a very important topic. In lesson 3, we are going to talk about ensemble learning, random forest. The previous 2 lessons we looked at decision trees, single decision trees. And you try to recall what the goal of supervised learning, regression, and classification. You always try to minimize the errors on training and testing. Only then you model correctly, accurately. Accuracy should be always good. Okay? We talked about confirmation matrix and MSE, mean squared error, etc. They should be small. No, the confirmation matrix should be closer to 100%, and the mean squared error or root mean square error should be as low as possible. So when you when you think of machine learning, so on supervised learning, there are 2 options. Build one really good model. We try to get an accuracy of, try to get a confirmation matrix accuracy of 1 in the case of classification, and try to get an accuracy or mean squared error or root mean squared error closer to 0. But this may be very difficult. Some people say it's impossible. But the other option is you build many models and average the results. Theory of averaging. Okay, that's called ensemble learning. This is a more recent development. Don't depend on one model, make more models for the same data set and try to find an average or look at the majority. So ensemble methods are machine learning techniques that combine several base models. The models are the same, decision trees maybe, but more number of decision trees in order to produce one optimal predictive model. So you have number of models, check their accuracy, and choose the best model, and that model use it for further use. So learning algorithms that take a set of classifiers, ensemble methods are learning algorithms that take a number of classifiers and classify any data using strategies such as majority vote. Suppose you have 10 decision trees and you are talking about the IRI dataset, and if 10 out of 7 say it is Setosa, you conclude as Setosa. Okay? That is, you take the majority vote in case of classifier. In the case of regression problems, the new data is average. You find out, the not only the error, but the predicted value y predicted for a given input data. Then you take the average of that. It can be simple average or weighted average. So 2 methods. One is taking the majority in case of classification, and taking the average of the predictions in case of regression models. The philosophy of ensemble is very interesting. You build many models and combine them. Only through averaging do we get the truth. Averaging is a good technique for many applications. It is too hard to build a single model that works best. 2 types of approaches: model that use randomness and model which do not use randomness. So ensemble, there are 3 approaches. One is bagging, bootstrap aggregating, So B and AAG. See, look at how the bagging word comes. Bagging is not a simple word. It's a combination of B, AGG, ING, which is bootstrap aggregating. The second type ensemble approach is boosting, which you may say after a couple of lessons. The third one is random forest, which is bagging little modification. So in this lesson, we will be looking more about random forest. Bagging or bootstrap aggregating gets its name because it combines bootstrapping and aggregation to form one ensemble model. Aggregation is through voting and averaging. Bootstrapping is random sampling with replacement from the available training data. What the training data contains? It contains features as well as the values of predictors, that is independent variables. So you do random sampling with replacement of those. Bagging is bootstrap aggregation is performing it many times. Bagging is performed many times, and training of an estimator of each bootstrapped dataset. Given a sample of data, multiple bootstrapped subsamples are pulled. You take from one sample of data, you take multiple samples and give it to the sedition tree, for example. A decision tree is formed on each of the bootstrapped subsamples. After each subsample decision tree has been formed, an algorithm is used to aggregate over the decision trees to form the most efficient predictor. So that's how the bagging works. So we have seen this. The bagging algorithm, you are given a data D of n training examples, x1, y1 to xn, yn. X can be a single feature or multiple feature, but y is always one response variable. So algorithm says for m is equal to 1 to m, capital M, lowercase m is equal to 1 to uppercase m, obtain bootstrap sample dm from the training data D. Build a model gmx from bootstrap data dm. Okay, so you do it m times. Okay, you take the sample data and build a model again and again. So set up m approximately say 30. In the case of regression, y hat means the estimated value of y is equal to 1 over m. Sigma m is equal to 1 to uppercase m, gmx. Whatever the values you get, you take the average. Suppose you have taken 10 models, all the values you take, when you are trying to predict the response variable for a given feature variable or independent variable, then the response variable you get from 10 models, you take it and average it, you get and assign the value. That's you get the value for corresponding to those 10 those independent variables. In the case of classification, we vote over classified outputs. So suppose the churning problem, 7 out of 10 says you'll quit, yes, he quits. Okay, the majority voting. Bootstrap a sample of n instances obtained by drawing n examples, training examples, at random with replacement. I keep on shuffling and taking. On average, each bootstrap sample has 63,000% instances. Training examples, 60% training examples. Encourages predictors to have uncorrelated errors. That's how it works. That's why it works. So we'll go to random forest models, which is one of the very good examples of ensemble learning. It can be thought of as a bagging method with a slight tweak. When deciding where to split and how to make decisions, backed decision trees have the full disposal of features to choose from. So the features, where you start, that's very important. All the data is on top on the root. So when you do the bagging, you will not put all the data, some 10%, 20% data on the root. And also you have all the features, which feature you start with. That also varies from trial to trial. Therefore, although the bootstrap samples may be slightly different, the data is largely going to break off at the same features throughout the model, throughout each model. Random forest models decide where to split based on a random selection of features. Rather than splitting into similar features at each node throughout, this is what we do in decision trees. Random forest models implement a level of differentiation because each tree will split based on different feature. See, that's how he builds in. He tries to get an average, That's how he does it. This level of differentiation provides a greater ensemble to aggregate over, producing a more accurate predictor. So how to implement random forest? Again, we will implement using the Jupyter Notebook, which I have been using for quite many examples. So random forest is an ensemble of CORT, classification and regression tree. So yes, you can implement random forest for classification as well as regression. So each decision tree is built from bootstrap samples and randomly selected subset of features. So the features are not the same. And they are without replacement. Say you may divide the features into 3 or 2 or 3, 4 and shuffle it. So you have different data, not entirely. So the data is not the same for every build. And the features are also not the same for every model. What are the hyperparameters of random forest model? How many trees you will build? Number of decision trees, 10, 20, 30, 100. Number of records and features to be sampled, that is the data size, m, small, lowercase m. Either Guinea impurity or entropy. These are two choices in decision trees. And you need to have random forest classifier, which is available in sklearn ensemble. So you have to import that. Import from sklearn ensemble random forest classifier. And you have to specify n estimator, that is how many times you will repeat, how many trees you will build, and what function you will use for measuring the split, quality of split, impurity, split impurity, how to manage, Guinea or entropy, and the maximum feature and maximum depth. So let's, I have a few examples, 3 examples in this further lesson. The first example is it's ensemble using entropy. And I'm using customer churn data frame. And I got a better accuracy because I added more features and used ensemble learning. That's example 1, which we are going to show very shortly. And example 2, before that, I'm also printing a classification report, a summary report at the end of the classification. The classification report function in sklearn generates a text report that provides a comprehensive overview of various classification metrics. For each class, suppose it is churning, the 2 class 0 and 1. If for iris, the 3 classes, 3 different flowers. The report is only applicable only for classification. You can generate the report only for classification. The report includes the following metrics for each class: precision, recall, effort score, and support. Support the number of actual occurrence of each class in the true labels. See, we have taken about say 150 samples, and class 1, that is customer churning, And how many example customer churning is positive? That is called support. It represents the number of samples in the dataset that belong to the specific class, 0 or 1. Accuracy is an important measure. It measures the overall correctness of the classification model. It is calculated as the number of correct predictions divided by the total number of predictions. True positive by true positive plus false positive. The total, the total number of true positive over the total number of predictions. While accuracy is an important metric, it should be interpreted with caution. The classification reports are organized in tabular format. Okay, you will see that very shortly. So for the example 1 I have taken, this is the report I get accuracy. That's not as part of the report, classification report. I got accuracy separately. The report is here. 0 and 1 are the classes, customer churning or not. So you get a precision like this, and recall and the effort score and support is 125, 155, and 25. Total is 180. Okay, got it? So, and accuracy is 0.92 approximately. Okay, this is a report you get by asking for classification report as part of your program. So the next example is the same entropy, but I do it by any data set. Ensemble using entropy. The third example I take is with Guinea, Gini or Guinea, whatever you call it. The report looks like this for Guinea, it is 0.996, and this is the classification report. We're getting one precision of 1, and iris status of 1, and Virginica is 1, and so on. Recall, support, all that. Totally 30, accuracy is very good, 0.30. Total samples are 30. Okay, this is how. So these are 3 examples we are going to look at in this example. Now I'll switch over to our Jupyter notebook to show you the actual implementation. Okay, now this is the first example. We solved it with Jupyter Notebook, that using entropy, and the libraries, all the same libraries we were importing again and again, but we have to import it. There is the data set, the customer churn, and I also took the columns, details of the columns, and we can also print the head if you want, head or tail, whatever you want. Head means first top 5, tail means bottom 5. Then I have to assign x and y. See, here x I am taking 1 to 5. Say 1, 2, 3, 4, 5. The names doesn't matter. Okay. And the churning or not is 9. 9th is churn. True or false. So I get x and y. And I split the data set into training set and the test set as usual. I got it. The total 900 data sets, 900 training examples, 720 for training, and testing it will be 180. So how do we build the random forest classifier? So from SQL ensemble, import random forest classifier. And we also import accuracy score and the classification report since we want to take it. See this. Then you create a decision tree. The random forest, not decision tree classifier. You create a random forest classifier. random forest classifier, okay, with splitting criteria as given below. You can take this out. I'm going to use Guinea. No, I'm going to use entropy. And I have the n estimators assigned 10. I chose some 10. And random state 0, fit extend weight line from CLF extend weight line, predict y predict x test. These are the predicted values for corresponding to the test values, test data. Accuracy is calculated like this. Okay, let's run it. And also I can print the classification report straight away. Y test, Y predict. So accuracy is 0.91 and precision 0.94 and so on. Recall the accuracy repeated here 0.92 for 180 samples. It took only 180 total samples. Okay. So this is the first example. So what for decision tree we are using a random forest classifier, and we call the class and create an object, and object.fit gives you the fitting. Then you can predict it and find out the accuracy as well as the classification report. Okay, now we go to the second example I have taken, that is using the same entropy. Okay, but I use IRIS dataset. IRIS gives you better results, although this dataset contains only 30 training examples. These are the columns there. These are the features: sepal length, sepal width, and petal length, petal width, and species is the name of the flower. And assign X and Y values. Now you split, test and training split. Now the same program, random forest classifier, and estimate is 10, entropy, random state 0. Same parameters, you get accuracy of 0.96. You can also print the confusion matrix. You will get the same result for accuracy. Okay, 96. Okay. So this is the second example using entropy. Now it is time for us to take an example with Guinea. Okay, so import all the files. I'm using the IRIS dataset. Okay, I'll go here straight, but the X I have to assign. X and Y. Splitting also I do. Now I run this. So I get accuracy of 0.96, but very interestingly, a lot of precision is 1 for IRIS. And versicolor recall is 1. And Virginica precision is 1. Accuracy is 0.97. Okay. So what we have done in this lesson, I have explained to you what is a random. I explained to you the ensemble and random forest classifier, where we take number of models, and the number of models is indicated by what? N estimators, 10. And we use Guinea as well as entropy, and we got the results. So that's all for this lesson. Please go through the slides and try to do the program yourself, and you will get the same results. That's all for now. Until we meet again. Bye-bye.